having me here. I love every opportunity I have to come back to Europe. Today, we're going to talk about human AI symbiosis with XR. I have had a bit the audacity to also put a math lesson inside the slides, so I hope that's going to go well. Probably many of you here already have heard about some of the topics, but I think it's very basic at this moment, aligned also with the prior talk about how we need to have more competence on what AI is. And then we'll go into how can humans be augmented with it. Let's look in a retrospective to start about what it means to digitalize something, Stockholm, for example. Historically, we have seen a convergence of analog and digital worlds. Before digital, of course, only analog. But once we start having some digital systems, we see how they just live isolated from the analog world, right? You would do things in computers, nothing changed in the real world after you did that, which is the pre-internet PC era. The moment we enter to internet, we start having smartphones, we can start interacting with the real world, like call a taxi in front of me or book that room for a trip that I'm doing. So we start seeing how really it goes both ways. You can actually change how the real world or the analog behaves. And finally, we're now moving into this blended era where the digital and the analog are hardly distinguishable. And it's a blended era of AI and augmented reality. And this is what it looks like, right? It looks like in situ information that gets changed when you need it. You can interact very easily. You don't know if you're interacting with a digital entity or an analog entity anymore. About 10 years ago, and we have 2 more years to get here, I made some predictions while I was at Microsoft. And I say that virtual reality systems will provide very rich multisensory experience that will blend or alter perceived reality. This got me a bit into trouble with some of the media attention for this was a bit overwhelming. But I do think essentially we're getting there, and you'll see this through the talk. I now lead the blended research devices team at Google. And before I was at Microsoft Research, working on perception and cognition. I will start now going into another retrospective, which is more state-of-the-art. State-of-the-art of what AI can do right now. So we can understand where we're going. AI can generate anything. And it looks utterly real. You don't know if this was really recorded or not, right? So it's starting to be this additional cognitive load to differentiate reality from non-real. Just when we were getting over the additional cognitive load of truth and false from post-AI era, post-internet era, now we're getting to the real, non-real. This has happened in a generation, right? Like when I was a kid, all you need to learn was what's good, what's bad, right? That was all your ethics, all the morals you needed to go around your life. Now this is changing so much. And it's becoming very rapidly a thing where you don't even know anymore if this was a real kangaroo wearing real glasses in front of the Opera of Sydney, right? Is that even possible? Because it really looks very, very possible. So we can generate humans' voice, like this is a generated
force,
person.
A wild, untamed might. And she commands your awe with every breaking light.
So you can see how it will have impact on movies, on any media. But you should, from now on, every time you get a call from your mother asking you for 2,000 euros, wonder if it's really your mother, right? Then there is this other part of AI that is bringing on the table. It's not just this idea that you can generate things, it's that it can really understand things. Until now, computers require computerization of data. You needed to CSV file every data you wanted to them in a particular way for them to understand it, or you get a parse error on your system. That's over. You can feed the AI with whatever data, and it will understand it. An example.
Clue 1. This country is the home of the kangaroo, the koala, and the Great Barrier Reef.
Oh, that's easy.
Clue 2. This country loves football and has won the most men's World Cups in football history.
Brazil, of course. Okay? So there we have an example of a system that can get total multimodal information and understand it like a human would, right? It's also providing this very interesting interface for even a kid could understand the question, right? So we're moving into this area where you can change formats of things however you want. If you haven't tried Notebook LM, I work with Notebook LM open. Every time I need to do any bureaucracy, Notebook LM does it for me, which is fantastic. You should try it. But basically, this idea that any format can be transferred to any format. So now we're going to get into maths. Because I do think there is a danger when you have a new technology that people haven't been following closely, that it looks like a black box of magic. And so let's open the box. In mathematics, the easy problems are always interpolation, right? So you want to know what the curve looks like in the point T5, and it's 3. And the hard problems are extrapolation. What is that point, right, in the future? And so it's very hard to know. Let's just say interpolation problems are just a search problem. You're estimating a value within a range of data points. And extrapolation is estimating outside the known range. So imagination and projection is what you need to do extrapolation. Traditionally, to solve extrapolation, you would need to have one of two. All the data, use some sort of symbolic regression, something that will give you an equation that describes the curve. Or, as humans did, have very good imagination and some luck. Because humans actually are an intelligence, so it has the capacity to kind of explore the data, and once you know enough, you can kind of extrapolate, which is similar to how AI works. And then comes machine learning, right? It does exactly what we said. A lot of data, then you move it to this other dimensional space, which is a latent space, and you, in essence, convert all problems to a search problem in this latent space, right? So if you have enough data, you do this. The big change has been to move this machine learning into being able to converge very large amount of data, right? So machine learning has been there for a while. Actually, last year, Nobel Prize to Geoff Hinton was because of the work they did, being able to converge very large machine learning models. This is how a machine learning model works in big lines. You have an encoder, you give the information, you encode it to this latent space, and a decoder, where we'll, given a query, provide outputs from that space. So there is the training phase, which you all hear about. Oh, this training needs so many billion tokens. And then the inference phase, which might end up happening on your own devices, right? Like it's getting so tiny. The interesting thing here is that the architectures of the gray box can be very different. So a lot of people are working on, should it be a deep neural network? Should I change this part of the architecture? In general, they all work the same. You put an input plus some labels, and that allows you to retrieve things through labels. Let's put an example. So here we have Katie Bauman, who input all the astronomical images in the world. There you see the hard drives. And a series of instrumental data from a telescope, which is basically 7 telescopes around the world, that is called the Event Horizon. And out of it, was able to retrieve something that is impossible, breaking the freaking laws of physics, an image of a black hole. And an image of a black hole that is correct. It's not just like a random generation of diffusion model. And this might be the face you make when at 29 you win a Nobel Prize. So it's not just to generate black holes, right? Like diffusion models, latent space there, you see, is one of the architectures that you have to generate the machine learning. And diffusion models start with noise and then like denoise, you can see there. And they get super accurate, not just on the black hole, but this Vermeer from the 17th century. Who are we to say that kitchens didn't look like that? There is a level of understanding in these models that they have acquired of the world that is mind-blowing. There is a training session in deeplearning.ai about diffusion models that is super well explained, and I highly recommend to everyone here. OK, cool thing is we can use this to solve, I would say, most problems of humanity, as we saw in the prior talk. We're going to solve protein structures already. It used to take one full PhD to find one protein structure. In 2022, Google DeepMind announced AlphaFold predicted 200 million protein structures. That's 200 million PhDs. And with that, we might reach to the conclusion that the AI might or not, still to be not be better than the best humans, but it will be certainly faster. So if you are seeing a horse, you don't race against it, you get on top of the horse. And they also won a Nobel Prize. Okay? So we're going to see a number of Nobel Prizes appear here, and it will be the next decade. I thought coming to Stockholm to saying this was pretty poetic. Fusion energy, I do hope that is also going to be solved. It's a bit of a harder problem because you need to add reinforcement learning, right? Like very real-time interaction and inference and training. So it's a bit of a different problem. There are some problems that can only be solved with reinforcement learning. Many of them are biological, but they will be solved. OK, that's all the math class. I hope now you have a better grasp about machine learning. But what about intelligence, right? Like we were just feeding data there, and it gets some very accurate predictions of extrapolation. So human intelligence, there is so much to learn about human intelligence. I never really cared about it until recently. If you want to learn more, Blaise Aguirre-Arca, a fellow Googler, wrote this book. It's very good. But I will sum it into this part of intelligence is defined by the people around you and your biology. It happens that until very recently, the people around you and your biology were exactly the same. And so that's changing. And that there are very different types of intelligence. And so we need to understand how we are going to augment through the different intelligences. And in essence, if the inputs we're giving are human data, the ML will display intelligence. That is the single difference about AI and the rest of machine learning. In particular, humans display intelligence through language. This is a generative pre-trained transformer. It's one of the most cited papers in the world. I recommend you read it because it's very important. It's kind of the invention of light. And they trained with all human text. Imagine a person who's read all the books and the whole of the internet and put it into this sort of attention model. It is different from diffusion that I showed in images before. This is an autoregressive generation. It's generating one text at the time. They're working on diffusion models for large language models. I think it's going to be very impactful. Imagine instead of having like the next word, just having like an empty page and words start popping up. And the first words that pop up are the most significant for your prompt, right? Like if I'm talking about Stockholm starts appearing. Then like there are less important words that will fill the gaps. So I think that we're going to see soon. Diffusion models have also the capacity to lower the latent space, I guess. So it will also improve on inference. One of the things there that I will say later also but it's like being second to the game sometimes is not the worst case. So in essence, AI one of the ways it displays intelligence is also through language. The cool thing is that we use language to do IQ tests. And last year, large language models were just below the human average. This year, there's several on genius category, okay, almost. You know, I think genius is considered over 145. And with every model, AI is displaying more intelligence, right? I guess it's about filtering which part of the internet is the one you should pay attention to. So, as we mentioned before, there are parts of these models that must have embedded world knowledge. This is one of recent papers that we did on foundational AI, my team. Looking at the attention layers of the model, you can see how, as you generate images, you can also see how they are generated in segmentation. So there is an understanding of, I'm going to draw a person, I'm going to draw the sky, I'm going to draw the trees. This is embedded in the model. I do think that there is more work coming on understanding how these encoders really are encoding information, how the decoders are decoding information, how it's all being abstracted. And there will be more of this, and the more we do of this, the more we understand the systems. In sum, AI displays intelligence, can generate anything and understand anything, so you end up with things like this. This is a complex thing, right? You're doing organic chemistry.
Of course. Is this the problem?
Yes, I don't really
And you can have a
understand what to do
kid
here.
walk
No
through it.
problem. Let's take this to the blackboard. The key concept here is optical isomerism.
Got it. But how can I tell if an isomer is optically active?
Optically active compounds require a chiral carbon atom. A chiral
So there are a
carbon
number of
is one
things
that is
here
bonded
that
to
are
4
totally
different
staged,
groups.
right?
Okay, awesome. That
This
makes
person
sense.
know what they
So
need to
how do I
ask.
apply that
I don't
to
think
solve
that's
this
true for
problem?
most people who use AI. And at least my kid, I bought him this rabbit. We don't have a TV at home, so I get him like gadgets. And all he asks is, what's the biggest blah, right? He's 7. So, I mean, there is a limit on discoverability that humans have, that it's radically important to start retrieving this intelligence from another system, whether human or technological. And that links with the impact of AI on humanity, right? There are like 3 buckets, mostly. I would say 4 even. These replacement people who want to replace humans. The adaptation people, which I just like not very optimistic, but they're like, oh, we need to adapt to this. I'm okay on board with that. And then the augmentation people who say like, oh, we totally need to use this to augment humans. Everyone in this room has experienced the wonder of being exposed to a higher intelligence and what that does to you, right? Even as a kid, you just learn. It's crazy how much you learn when you are exposed to the right intelligence. So augmentation is very much something we can do. And yeah, regarding replacement, there's ways in which we do want replacement. I don't know if you've seen this quote, but this was a woman saying, I want AI to do my laundry and dishes so I can do art and writing, not the other way around. And so we all want AI to do some things for us. And there are certainly, for example, examples of the physical reality that were presented before that we're just not even doing, right? So we should have AI do it for us. And as I say, adaptation is something we will have to do. There is no doubt. Just people start pivoting there because with every new technology, you see people who fall behind, right? Like the typical grandpa who never got to use the phone, or you're like, yeah, you're kind of like losing your agency in the world, right? So I do think that there is a need for that. Let's talk about the most interesting thing. Will we be replacing humans or augmenting them? There are a couple of examples here that I wanted to show. This one tests physicians. Okay, so you have here physicians are the dots around. Using a GPT or just the AI on its own, doing diagnosis. Okay? So here you see how the AI is performing much better than any of the other cohorts. And that is true, But it's also true that it's not performing better than the points at the top of any of the cohorts, right? So AI is at best better, not better than the best humans, but it's certainly better than the average and much faster, right? So we need to start figuring out how we make AI improve all these people at the tail to go up, right? So it really shows that there is potential for replacement for the average human. There is still not potential for replacement for the top human. And so the case for augmentation, I am not the only person working on that. There is this work from Pat, many other people. Pat did this image. He just started a new team at the Media Lab of how, yeah, we have all this progress on artificial intelligence. We should use it to do intelligence augmentation so we can have a human flourishing. There is a lot of humanism happening now in tech. It's kind of overwhelming. Sometimes it doesn't really let you sleep. The case for human augmentation. Let's go for this, because I think that after reading this paper, I became far more optimistic of the chances. So here we have a paper that the cool thing about AI is that we drop it into the world, and it was adopted exponentially. Everybody who was doing digital was doing AI the day after. So let's look at YouTube videos, YouTubers. YouTubers before AI, YouTubers after AI. We look at 7.35 billion words in all these videos. And you can see how YouTubers, after AI appeared, they have improved verbosity, vocabulary, and articulation inside their podcasts. And this happened just because of AI. They were exposed to it, or they were secondhand exposed to it. Because humans are very much collective society, right? Like there is this new trend word, 6, 7, and everybody starts saying it. So there is something about how we copy each other, the mimicry, where exposure to LLMs might actually increase collective IQ. And so we're going to see this incredible exposure, because before we say the people versus biology, well, now we have this other intelligence system we can interface with. 1 in 3 houses in the United Kingdom has an Alexa device. They're one single over-the-air software update to have the access to this. I wonder a kid who is in this phase of their lives and why, and why, and why, what does it happen there, okay? Because the AI has total patience. So the fact and the cornerstone of all the things that I've been saying is that humans will need to interact with AI to be augmented. We're not talking about all the incredible things AI does on compute, right? It solves humanity's problems for us. But how about augmenting humans? Very interesting, because I worked in XR, AR for my whole career, and I had AI on the side in parallel. And I was like, oh, that's cool. Let me do my avatars. And so all of a sudden, we realized that AR is to AI what screens has been to computers. It is a device that you wear, that it sees what you see, and it has a display to basically embed anything in the world when you need it, right? So it really is the device to consume AI. And that is exactly what we're doing in our new operating system, right? We're bringing AI to a series of glasses of different types that will allow you to interact with the real world in very different ways. I always think of how technology tries to build things before other things, like evolution. There are some prerequisites for you to make a leap. And I think AI was a prerequisite for augmented reality. Like, I mean, it was great that we made a lot of progress on it before. In the same way that phones were a prerequisite for augmented reality, because you needed to have smaller cameras and smaller chips, and phones afforded all of that. Despite what I'll show you later is going to be very forward-looking, my team has been solely working for the inputs of the operating system. we want to have very precise inputs that are very easy to use for people, because that's a scaffolding for interaction that is very important. So you can use your gaze and pinch. You can use direct touch. You can use hand ray. And this is very important. You can use your mouse, okay, because it's backward compatible with everything people know. And they don't have to learn a thing. They just grab their mouse, and they have a virtual reality system. And this is coming by default on the operating system. For me, it's very important that people have access to very high-quality interactions, that they don't need to go to the settings and be like, now I want to use the mouse. No, everything transitions very naturally. And we actually brought some guidelines on how to bring productivity to virtual reality. So now let's go into, OK, yeah, precise inputs. But I want to know how I interact with AI, right? Well, let's start by saying humans have many limitations. We have finally built a technology that is, in many aspects, much more proficient than ourselves cognitively. First of all, speech is very slow. This idea that you're going to be talking to your AI, we should get over that very fast, right? This was a paper in Science Advances across almost all classes of languages of humanity. We are as slow as a router. I'm old enough to know that. But it's very slow, OK? Not very clear if it's because of encoding of language or decoding of language in the human brain, but basically, even languages that talk very, very fast, like Japanese, they still have the same information ratio. I don't know if you watched this movie, Lost in Translation. There is one scene from Sofia Coppola where they're talking very, very fast, and then the translator says like one word. And you're like, and the guy is like, didn't he say more things? No. So that's it. And then prompts are very complex, right? Like, you're not going to be like, hey, can you revise this email? Let me copy it to you. And then, you cannot just say all of that aloud. So the combination of the two really interacts very badly. Plus, non-AI experts systematically fail to do LLM prompts. This paper of Why Johnny Can't Prompt. I was like, wow, this is a super cool name. Bjorn Harman in Berkeley. Very interesting because they describe the 7 stages of building a good prompt. OK, so do read this. But anyway, you go to the internet. You don't need to go to Berkeley. And it's full of things like this. These are the 9 points you need to do a review prompt. Very interesting things you can learn also from the internet. However, to me, prompts look like we're going backwards. We're just going to some sort of command prompt again. Wow, I thought we were over that. And also, actually, some work from Antti Aula-Virta here in Finland, next to you guys, on cognitive needs for different UI interactions. And so the whole of the field of human-computer interaction has basically dedicated to make things more simple, so you need less experience and less cognition to use computers, right? Because as we agreed before, there are some things that if you cannot use, you're basically kicked out of society. So there is a need to lower this curve completely. Up here, I mark command prompts. You need super high cognition and super high experience to use Linux. So we cannot create an AI that looks like Linux. Despite some people are saying like, oh, AI is going to render operating systems obsolete. I'm like, no. We need a layers of interaction between the computation and the cognition of a human. This is from a PhD thesis from Hai-Jun Xia. He did it in Toronto. And I think it's just brilliant, right? Like, there are so many layers we need to improve from AI to be able to interface with humans, as we said, many limitations. It basically sums up on, let's use paradigms humans understand, right? Because we have been interacting with technology long enough that we can reuse all of that learning. And so it's very simple. You can just interact with your own hand. And I got some of my students recently, and we brought this vision paper. When you are an academic in industry, you have many students, but they are only there for 3-4 months, so you get to fix one thing from them, just one thing. And the only thing I fix normally is you can go much faster. This is another example of a paradigm that people can understand, a menu. So one of the things you're seeing here, the circle to search, this is that you almost never need to talk to it, right? And so the whole problem of speech and prompting is reduced through this interaction. There is a lot of work to be done in pipelining AI to the layers of interaction. So here you have things that we already had of anchoring, etc., plus the AI there. In the end, if we achieve bespoke interaction paradigms, we will unleash complex AI interactions that will also feel natural. This is a recent paper of ours. It's called Reality Proxy. So the cool thing here is that we're adaptive to very complex environments, very easy to interact in ways people already understand. And then you can add AI on top of this selectivity, right? I always, when I see these AI demos that have one object in front of them and they say, what is this? I'm like, man, you should see my desk. Right? The reality is far more cluttered. Things are far away. You're saying, what is that? And what that? Right? So demonstrative pronouns are very important for humans, and AI needs to interface with that. You shouldn't be like a super description. I want the third flower on the row. You know, what is that? And just like, what is the third flower? Starting from the left, you know, we could end with very long conversations just to get a very simple thing that I'd be like, take that one. So this is bringing us towards symbiosis, right? Symbiosis is when we start to leverage this AI into our world. So I ask you, what do these books have in common? And it will take you a while. Instead, AI already knows. They are all by the same author, right? So AI has developed this understanding of the world. We can retrieve information from there. And we, you know, it is very important that we start surfacing this, also because it will help us create theory of mind with agents to know how they're going to interact. And so this is the kind of semantic relations that you want to have.
Ultrasonic sensor data on the LCD screen through the Adreno board.
To show ultrasonic data on the LCD,
So here we have an example of a much more complex question. Right? I want to connect this ultrasonic sensor to the LCD screen to maybe build this nose for physical AI. And so how do I do that, right? I want to have this idea that you have semantic information around you driven by the AI. This paper will hopefully be out very soon. Still, even with all of that, humans still have more limitations, right? We need to have the discoverability. We also have like a lot of types of memories. It's very hard to remember things, as I say, my kid. And agents will bring these gaps. Agents will suggest actions for you, so you don't need to remember that what's the biggest is the only thing you know. It will just provide you prompts that will be interesting for you to learn. And it will also interface with your attention. For example, here, there is an agent, this cute thing here, who is going to just have no clue about your context, or have a lot of information from your gaze, what you were looking for before.
So that instead of this,
Can you give me an idea for this competition?
Could you give me more information about the competition?
Typical
we can
answer.
have this.
Can you give me an idea for this competition?
How about creating a doodle that envisions a world where education is fully immersive? With students learning through
just share
interactive
the context
holograms,
with the AI.
your doodle
It
could
will be
illustrate
much
children
better.
around.
Before we were seeing the one with the picture of sharing context. Well, if you're wearing glasses, you can't even know where you're looking. And so you can have these fixations and then know around it. And they can create common context, serve as your memory, right? Like have all
depends
these
on the scene's textual
heterogeneous
density
or
and
not, granularity, length of window, etc. So what's next? We have the first device
To
out.
bring Galaxy XR to life,
You
we
can
had
watch
to
this
rethink.
at home. It is the first device that is affordable, I would say, that it will also have many software updates. Like I see the hardware, I'm like, oh, wow, we can do so many things later with this. And currently, it's very good already. I'm like, wow, it's going to be. And so I do think we're going to the blended reality that I predicted 10 years ago, where we're going to basically live in a world where we can have all sorts of things happening to us, and we just don't, they look exactly like real, right? This one here on the right, it's mind-blowing to me. You can just like live in a world where you change your husband face forever, right? It's just like, blows my mind. So I want to end with a provocation that nature used to be the main behavioral training tool for humans, and now it's technology. And let's embrace it in the best way we can. Just my team, a lot of students, collaborators. Thank you.
Yep. Thank you.
Yeah.
So let's get going with the questions. We have a few minutes for plenty of questions. One of the most important ones, or the most common questions here that I find interesting is too, so there was this paper that you showed that claimed that using ChatGPT can increase your vocabulary and use of language. But there are also studies showing that your cognitive competence might be, that we actually become dumber by using AI. So what's your take on that? How do we use AI, for example, that supports our memory without getting an even worse memory and getting even dumber?
Yeah, I think it's a matter of effort that you put on it, right? For some people, 30% of the world population has some sort of dyslexia. And for them, these tools are basically affording them to be just a regular person in the world, right? So we need to be careful with this idea that, oh, you shouldn't use it or should use it in some ways. But I do think that people should not outsource all the effort. This is a choice you make, the same choice you make when you enter your phone and decide to go to a news site instead of a social media site, or, it requires some agency of.
But also a design choice, right? How we design these systems.
Yeah. Well, certainly, if you don't make them interactive, you don't give the chance of an alternative, right? The fact that you can, perhaps one way I use it is like I write something and then I send it, and I'm like highlighting bold changes that will improve punctuation, right? So my level of writing is good enough that I only want to check punctuation marks. For another person, is like, oh, can you make sure there is like intro, development, and like the end of the story, or like different people will need different things. I think it's very important that it's met where they are needed.
This is interesting too. What's your view on, since you had a few cases there too, the impact of AI on education? What does the future school look like from your perspective?
Yeah, I think kids should learn to do maths before they use a calculator. Similar. But I think for productivity, as you become an adult, most of your work should be on how much impact you have for the world. As I say, don't try to run without the horse against the horse.
Great. Great answer. And I find this question interesting as well, since you have been sort of active in the intersection of academia, but also big tech companies. It seems like these days, a lot of AI research is coming from the big tech companies rather than universities. How do you feel about this? Is it true? And how do you feel about that?
For now, it's been a very high investment thing, which only large corporations perhaps had the muscle to do. I think we're seeing this becoming much cheaper. The models are becoming smaller, faster, easier to train. You can run them anywhere. Do some post-training on top of them, prompting. That makes it easier to do this last mile. The good thing about the universities is that they are very well implanted in local economies. So they have this capacity to later reach the last mile much more and impact on adoption in their economies much more than a large corporation can. Same for a lot of consulting firms.
So an interesting question is that we've seen these smart glasses, augmented glasses come and go, try the market, sort of, but we're not really ready for them. What is the case? What does the case look like right now? Like, obviously, you sort of touched upon it, but why do you believe that the time and that we as users are ready for smart glasses now and not just using our smartphones?
I think there is this long tail of innovation where many times also we confuse prototypes for products, products for prototypes, So I do think also, as I say, that the technology is evolution. We couldn't be here if we didn't have internet before. We couldn't, So I do think that the AI was certainly a prerequisite of AR. There are some things you only find in retrospect, and this is one of them. Because I often say the VR, you need to nail VR before you can do AR, right? You can have larger sensors. There is a total understanding of your virtual world because you're synthetically generating it, versus the real world, you have no understanding of it. Well, that's gone with AI, right? So there are like a number of restrictions that you had before that I think we're over now, and we can finally have AR.
Super cool. One last question. Looking even further into the future, I know that you've been at the Media Lab, MIT Media Lab as well. The Media Lab has sort of a 10, maybe even sometimes 15-year perspective on things, or horizon. So what do you see 10, 15 years from now? What type of society do you envision?
Yeah, I did that once. I don't know. We're seeing so many changes so fast. I do see humanity evolving significantly out of many dogmas. Even on the Western civilization, we have had tremendous dogmas over the last decade or two that have to do with transhumanism and how much technology we accept in our bodies. Intervention from humans on humans, right? Which before it was not even possible. I think we're babies still on figuring that out. I think we'll have much more maturity on this now that we're going to be able to, the protein folding thing is a prerequisite to solving cancer and all medicine because we're, interacting with proteins in a biological level. So I do think we're going to have this capacity to solve some things that we're going to have to make decisions as humanity of what shape us. Very interesting times to be.
But it definitely requires ethical perspectives on it.
Yeah.
And other, again, with MIT Media Lab, the thing there was to actually gather people from very different areas because you need different perspectives on it.
I mean, I'm sure many of your colleagues are now in tech. They are the same people. They think the same. I think there is a very important humanist trend in tech. We are the applied maths lab of the world, and we take it very seriously. I think there is perhaps an interface issue where the regular folk hasn't got that memo and thinks we're like some sort of evil platform, whereas I think we provide basic services for the world almost for free. If you would have governments have to implement their own version of internet one by one on taxes from people, man, that would be a chaos, right? So I do think that there is also, in a complex society, everyone plays a role, and it's important to see objectively how some roles are more efficient in some particular spaces than others. I, for once, love that Wall Street is bankrolling all the research that we're doing.
Sorry, what?
Wall Street is bankrolling all the research that we're doing, right? Like, I mean, it's for everyone to use, paid by a stock market.
All right, let's discuss this afterwards. Yeah, super interesting. Thank you so much again, Mar, for joining us. Thank you for asking great questions.